Yeah, so the project was a spatially explicit Bayesian network. So in southeast Queensland, we have a lot of information and research on the importance of riparian ecosystems for water quality and biodiversity benefits. Um, but we needed to synthesize this in a way that was more useful for end users, for decision makers that are making decisions every day about where to enhance areas or restore areas in the catchment. So the work produced a prototype end user visualization. So it's basically an end user interface that allows decision makers to explore scenarios of catchment investments and the predicted benefits of those investments for water quality and biodiversity outcomes. It was developed in conjunction with end users in southeast Queensland. So we worked with local governments, water service providers and bulk water suppliers to define what some of the key outputs of this model would be. So there were three main work components. We engaged with end users to explore what the key outputs of the model would be of most benefit. Then we developed the Bayesian network, so we worked with experts in the field of catchment management and riparian ecosystems to develop a model. We then drove that model with some underlying spatial data. So we synthesized spatial data to drive the model to produce a prediction that was useful for end users. So key learnings. So this is a rapid development exercise where we've basically taken an end use case and a rapid development exercise to develop a working prototype. We've identified a number of gaps that could be filled to enhance the prototype and refine it. So in southeast Queensland or Queensland, for example, we have limited information on catchment and river attributes at a spatial level. There's also some conceptual challenges with translating that into ecosystem service values. So we think there's a lot of potential in this type of work, but there's a lot of refinement that needs to be undertaken for people to be confident in the predictions of the model itself.